We are going to do 2 lessons today, but they're actually both pretty easy, so I think I can get them both done today without any problem. I did in the other class, so we should be able to do that in here. What we're going to talk about today is volume. I'm not going to go into a whole thing about volume. You learned about volume when you were a little kid. It's basically how many cubes can you fit inside of a solid object, okay? So instead of how many squares can fit in a two-dimensional object, it's how many cubes can fit into a solid object, okay? So that's what we're doing. We're trying to find the volume of something. So we have, yes, it's absolutely cubes. It's cubes. All right, so let's keep going. So let's do this. We're going to find the volume of a prism, right, or cylinder. Because a cylinder basically is a prism. It just has a what kind of a base? A circular base. All right. So a cylinder and a prism have the same exact formula because they're basically the same thing. We just, for some reason, with circles, we give special names, and that's why we gave it a cylinder. And here it is. So the volume of a prism or a cylinder is just this. It's very similar to what we've done before. It's the area of the base times the height. And that's it. That's the volume of a cylinder or a prism. Prism or cylinder is the area of the base times the height.
So then, like, if you're doing a cylinder, you just do the
yeah, if you're doing a cylinder. Yeah, first. Now look, some teachers have you memorize different formulas for each different figure, which I think is a waste of time. Know the general what am I trying to say? The general formula for this, and you could do almost any of these figures as long as you can find the area of that particular base. You can find the volume of that prism or that cylinder depending on what the base is. Now remember, a prism or cylinder, it has to go up at right angles. Actually, for volume, it doesn't have to. I'm sorry. It doesn't have to go off at right angles. For instance, let's put a couple in here. Let's put this one in here, and let's just scooch this down here like this. And let's do one more.
Is it possible for you to like to draw those shapes in your program, or is it like, does your program only allow you?
Yeah, it does. This is a lot easier. Okay, so look, I've got 2 cylinders right here. This is called a right circular cylinder because this side makes a right angle to the base. Okay, it goes straight up. Okay, that's what you guys like to say. Just goes perfectly straight up and down. The volume is the same exact thing. If I had this base, the same base as this, okay, so if the circle base was the same for both of them, it's still the same formula, but notice what the height is now. On this one, let me do a different color. On this one, the height started here, right? And it went what? Perpendicular to the base. Okay, so if the base is sitting right here, it's perpendicular to the base. You follow me? So that's the height. Look at the height here. Now look, the height doesn't go from here straight down like this because it wouldn't be perpendicular to the base anymore, would it? So what is it? It's from here. Now if I extended this base out, this would be the height. So that right there would be the height of an oblique. They call it an oblique cylinder. It just means it's not right. It just doesn't go straight up and down. All right. So even now that doesn't always hold. That doesn't hold true with surface area like we were doing before. On surface area, it had to be a right cylinder and everything had to go straight up and down. Right. But on volume, it can tilt. All right. So as long as the height, as long as from here to here is the same height as this, they would have the same exact volume. Make sense? So that's how you find the volume of that. It's actually pretty simple. That's 12.4, okay? 12.5 is almost as easy. It wears me out. Here we go. Let's do this. Let's make this a little bit bigger so we can see it. Now watch this. Let's pretend that I had a prism that had this exact base, all right? And I was going to take this and I was going to slide it. Let's say it's open, all right? It's got sides and bottom and stuff. And I was to slide this right into it. Okay, this would take up exactly 1/3 of that whole entire prism. This pyramid would take up 1/3 of the prism with the same dimensions, with the same height and the same base. Does that make sense? All right. All right, so this pyramid right here is exactly 1/3. The volume that it has is exactly 1/3 of the prism that has the same exact height and base. Does that make any sense? So then the volume of a pyramid, all right, is exactly 1/3 of the volume of the prism that have the same dimensions. So it would be what? 1/3 the area of the base times the height. That's the only thing different about a pyramid compared to a prism, like we did earlier. It's just 1/3. That's all you have to remember, is that the pyramid takes up exactly 1/3 the volume of as what the prism would take up. Okay, providing it has the same dimensions, the same height, and the same base, and all that kind of stuff. You okay with that? It's that easy.
Q.
For a cone as well, yeah. So a pyramid or cone. Yep, it's the same exact thing. All right. So a cone, if I took a cone and I was to put it into a cylinder that has the same dimensions, right, the same base and the same height, if I was to slide it perfectly right inside of there, that cone would take up only 1/3 of that whole entire volume. Okay? Does that make sense?
Yeah.
All right. So there you go. That's how you find the volume of a pyramid or a cone. It's just 1/3 the area of the base times the height. Now, of course, there's not just like one specific formula for this stuff. It all depends on what your base is, right? You might have a 5-sided, 6, 7, 8, 9, 10-sided figure. On the bottom, you got to find the area of that particular base. All right, but it's always 1/3 the area of the base times the height. Again, understand that the height has to be what? Perpendicular to the base. This thing could slant. I don't think I have a picture of an oblique one. I think there's a picture in the book somewhere. Yeah, page 849. Look at page 849. If you have your book open, there's an oblique hexagon. Do you see it? Just a hexagon, but it's slanted. But again, notice where the height is. What's the height of that thing? Yeah, it's 6.4, isn't it, on that example? Because it's from the top, it's perpendicular to the base. Everybody understand that? So there you go. I don't think there's anything else we need to say about that. I think that's pretty easy. See, I told you we could do 2 lessons in one day, and that's basically it. All right. Now, I skipped some examples, but I think you're smart enough to be able to go to the examples, look at them, and figure out how to do these things. But look, it's basically, if you know how to find the area of the base, and if you realize that the height is perpendicular to that base, make sure you use the correct number for the height. You shouldn't have any trouble with these things at all. All right? We good?
Yeah.
That's about it. I actually have a worksheet for you on this stuff instead of from the book. All right? So our last homework assignment will be a worksheet. Let's talk about the test for a second, the final exam. The final exam, I believe it's 7. Starts at chapter 7. That was the first chapter we did in the 3rd marking period. So we did 7, 8. I think we skipped 9, right? Then we went to 10. We did 11, and then there'll be a little bit of 12 on there as well. The stuff that we've been doing. Okay. So these are the chapters for the final exam. Now, what are your study sheets for this? Your old tests, that's right, okay? And you were asked to hang on to your old tests, all right? And if you don't have them, well, you're going to have to get them somehow. Get a friend that has it, make a copy of the front of it or something like that. But that's the only thing that's going to be a study guide. I'm not going to make up new review sheets or anything. The problems on the final exam will look very similar. They won't necessarily be identical. There could be a few here and there that are identical, but they'll be pretty similar to the problems that you had on your old tests. Okay, there'll be 40 questions, just like on the midterm. Okay, so there'll be 40 questions, and it counts 5% of your total grade for your marking period. Okay.
So you want to get a 0 and you have 100, you'll get 95.
I don't know. Well, it's I don't know. Go ahead.
In high school,
yeah,
everything after midterm is your final. It's not the whole year.
for here, it's only after the midterm, right?
Yeah, she's asking like on the final.
Yeah, they told us it's only the second half. Yeah, final exam is only the second half of the year, so it's not a cumulative, complete.
Okay.
So it's the second half of the year. Okay.
It's a lot easier. I did well on most of these except one.
All right. That's it. Let me give you the worksheet, and you can start working on that.